Good day, little knowledge seekers. Welcome to Math Pirate Show, where knowledge is the greatest treasure to hunt through high and low. Today, we are about to seek the mystery of two the most beautiful and amazing pattern and sequence that has ever graced the planet Earth. The Fibonacci sequence and the golden ratio. So, are you ready to set sail and explore the magnificent world of numbers and patterns? If you're ready to row, then let's go!
Before we delve deeper in our today's golden topic, let us first meet the man behind Fibonacci sequence, Leonardo Fibonacci. But who is Fibonacci? Dubbed as the greatest mathematician of the Middle Ages, Leonardo Fibonacci was born in Pisa, Italy in 1770 AD. Did you know Leonardo Fibonacci's name is simply Leonardo, but he used Leonardo Pisano, which can be translated as Leonardo of Pisa, as a reference of the city he originated? But when scholars studied the handwritten copies of Liber Abaci, they misinterpreted part of the title, which is Filius Bonacci, as his surname, which literally means son of Bonaccio. Thus, Fibonacci was born as we know of today. He spent his childhood in Beggia, Algeria, where his father, Guglielmo Bonacci, was appointed as a public notary and the customs for Pisan merchants. He studied in the School of Accounting in Algeria, where he was introduced to the art of Indian's 9 symbols by his Moor teacher. He traveled widely in Algeria before he was sent for business trips in Egypt, Syria, Greece, Sicily, and Provence, where he acquired a great deal of knowledge, especially in mathematics, before he settled down in Pisa on approximately 1200 and used the knowledge that he has gained on his travels to write his first book, Liber Abaci. Liber Abaci, which means Book of Abacus, introduced the Hindu-Arabic system based on 10 digits with its decimal points and a symbol for zero. The 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 to the Latin-speaking world. Fibonacci's book Liber Abaci, which was completed on 1202, was written mainly for merchants, though Italians were some of the Western world's most proficient merchant and traders during the Middle Ages. Mathematical calculations using Roman numeral system made it hard to do addition, subtraction, multiplication, and division that they have to personally keep track of their transactions, which was undeniably a hassle. Thus, Liber Abaci showed how superior the Indo-Arabic arithmetic could be applied to benefit the Italian merchants, as it contains practical problems and work examples about simple commercial and mathematical calculations such as addition, subtraction, multiplication, and division. But though the beginning of the spread of decimal numbers was Fibonacci's greatest mathematical achievement, he is better remembered for a specific sequence that appeared in Liber Abaci. And if you're guessing in your mind right now, I know you guessed it right. This sequence is one of our topic for today, the Fibonacci sequence. So, how did Fibonacci discover the sequence? The sequence was a result of a mathematical problem that was posed in Liber Abaci about rabbit breeding. In the book, Leonardo pondered the question: given the ideal conditions, how many pairs of rabbits can be formed in a year from a single pair of rabbits? This experiment artificially dictates that the female rabbits always give birth to pairs of rabbits, which consists of a male and a female. So, the problem starts with a pair of newborn rabbits in a fenced yard and left to breed. In the first month, the original pair of rabbits remains as they can't breed unless they are a month old. By the end of the second month, the original pairs of rabbit give birth, leaving a new pair of rabbits. In 3 months, the original pair of rabbit produces another pair while their earlier offspring mature. This leaves 3 pairs of rabbits, in which 2 will give birth to 2 another pairs in the following month. The total numbers of rabbits follows the Fibonacci sequence. So, after 12 months, Fibonacci calculated that there will be a total of 144 pairs of rabbits. That was then how the famous sequence was born. To totally understand how the sequence works, it will be better for you, little knowledge seekers, to be introduced to the first 26 Fibonacci numbers.
So, what is Fibonacci numbers? Fibonacci numbers are special kind of numbers that form a special sequence. Well, that's Mr. Google said. What do you think is that so-called sequence? To understand it more, let us first meet the first 26 numbers of Fibonacci numbers. As you can see in the screen, those are the first 26 numbers, denoted as f sub n, which starts from 0 onwards. But before that, did you know this sequence is an infinite sequence? In simpler terms, it won't end. So back to the topic. Observe first and find that so-called sequence. So, have you seen the sequence yet? If you haven't, then listen carefully for you to understand it. As you can see, the first ones are 0, 1, 1, 2, 3, and 5. To get that sequence, all you need to do is to add the first 2 numbers to get the third number, and so on. So, for example, 0 plus 1 equals 1. Thus, as you can observe and see, there are 2 1 in the Fibonacci numbers. Another example is 1 plus 1 equals 2, and 2 plus 3 equals 5. This pattern can then be repeated until you get 75, 0 to 5, to get the first 26 numbers of the Fibonacci numbers. To solve it using mathematical equation, you can simply follow its rule, where f sub n equals f sub n minus 1 plus f sub n minus 2. For example, to get the term 6, all you have to do is to follow the equation. So, f sub 6 equals f sub 6 minus 1 plus f sub 6 minus 2. F sub 6 equals f sub 5 plus f sub 4. Then, you have to substitute the term with its corresponding Fibonacci number. So, it would then look like this. F sub 6 equals 5 plus 3. Therefore, f sub 6 equals 8. Now, there you have it. That is how you can solve the Fibonacci numbers through a mathematical equation. So, in conclusion, Fibonacci numbers are whole numbers which are the sum of the two previous numbers, forming a mathematical sequence in which we all know as Fibonacci sequence. Isn't it easy?
If you think so, then can you see any interesting pattern lying between the numbers in the Fibonacci numbers? Have you seen anything yet? If you haven't yet, then let me show you one. Now let's go and observe. Let us divide it first into 5, including f sub 0 to make it more visible. Now that we have each 5, take note at every third terms. So, we have terms 3, 6, 9, 12, 15, 18, 21, and 24. So, what can you see about their corresponding Fibonacci numbers? Can you notice the pattern? What is your answer then? If you answered that are all multiples of 2, then you were right. 2, 8, 34, 144, 610, 2,584, 10,946, and 46,368 are all multiples of 2. Quite actually, there are lots of patterns that we can find inside the Fibonacci sequence. But it is for you, dear little knowledge seekers, to find out. Isn't it fascinating and challenging to think of patterns within a patterns?
So now, let us all move on to our last topic for today, the golden ratio. So what do you think is golden ratio? Is it really as golden as its name suggests? Well, golden ratio, as coined by Martin Ohm in 1800s, is also called as golden section, golden mean, divine proportion, or for a more humanized term, the most beautiful number in the universe. But wait, why do people think so? To understand, let us investigate the mystery of this golden ratio. This ratio appears in numerous architectures such as the Parthenon of Greece, art such as Leonardo da Vinci's Mona Lisa, in geometric designs, in nature, and even in the whole universe. Actually, even your face and body proportion can be solved using the golden ratio. No one is sure as to when this ratio first appeared. If it started in 2560 BCE with the building of the Great Pyramid of Giza, or if it is discovered and rediscovered across the time. But it was first described by the Greek mathematician Euclid as the division in extreme and mean ratio. One thing is for sure though, wherever it appears, it would make a satisfying view. So, why does it seem to be very important? Well, golden ratio is said to be appealing and beautiful to the eye. So, if something has a ratio nearest to 1.618, then it was believed that it looks pleasing, as what artists and architects think. That is why numerous artists and architects integrate it in their arts. Also, it is even said to be the key to understand the universe. South African researchers said that our universe is governed by the golden ratio. They stated that this number can be used to link everything in the universe. So, what do you think about this ratio? Isn't it amazing? I bet you thought so too. So now, let us meet this golden ratio. Denoted as phi, the golden ratio is about 1.61803, and the numbers go on. Did you know? Though the golden ratio can be traced back to the ancient Greece and Egypt, the term phi was not used until the 1900s by the American mathematician Mark Barr. So the two numbers are in golden ratio if the ratio of the sum of the numbers divided by the larger number is equal to the ratio of the larger number divided by the smaller number. Since we have two topics for today, how about together, let us find the relationship. So now, let us have the Fibonacci sequence in the picture again. Let's take the ratio of 2 and 3 to prove its relationship using equation b over a. So 3 over 2 is equals to 1.5. Well, this is quite near to the golden ratio, but how about using larger numbers? So let's take the ratio of 21 and 34. 34 over 21 is equals to 1.169. Very near, but we want 1.618. So how about taking the ratio of larger Fibonacci numbers? So now let's take the ratio of 377 and 610. 610 over 377 is equals to 1.618. Now there you have it. You already have a perfect ratio. So now, what do you think is the relationship of Fibonacci numbers and golden ratio? Fibonacci sequence and golden ratio have a special relationship, as any consecutive numbers of the Fibonacci sequence's ratio will be very close to the golden ratio. And if you can observe, the larger the number, the closer it is to the golden ratio. Another thing is that, as you can observe in the pictures about golden ratio and Fibonacci sequence, it always has a rectangle with an eye-catching swirling line in the middle. That rectangle is called the golden rectangle. The golden rectangle uses the ratio of the Fibonacci sequence to form a perfect rectangle to better illustrate the golden ratio. It is also to prove that the ratio of the Fibonacci numbers are very close to the golden ratio. See how closely related the two are? What can you say about the Fibonacci sequence and golden ratio? Are they as fascinating as it suggests? If you think so, then let us know in the comment section below. But wait, before we end, let us first show you some of our examples using the golden ratio to calculate the proportion of the human face. We have here our local celebrities and their ratio.
Marian Isabel with a total ratio of 1.042, Clarice de Guzman with a total ratio of 1.061, Angeline Quinto with a total ratio of 1.025, Regine Velasquez with a total ratio of 0.987, Merced Amon with a total ratio of 0.989, and Jonalyn Buray with a total ratio of 0.911.
Clarice de Guzman was the celebrity who came close to being golden, but she was also the celebrity who received the lowest ratings for attractiveness in the survey we conducted. That is all for today, little knowledge seekers. Until we meet again.